Hello, grade sevens. We are continuing on our unit of measurement and area, and today we are studying area of trapezoids. And just want to point out Abigail's name here and Jacob's name here. Good job doing your homework. You guys are doing awesome. So, um, so let's just review a little bit first. What is a trapezoid? So these are some different examples of trapezoids. So what can you notice about them? So there's some differences amongst these different trapezoids, but what are some common features? Well, you can see that there are four sides, so they are quadrilaterals. The sides are straight, so four sides that are straight. And can you see that in each case, two of the sides are parallel, like one pair. So there's a pair of parallel lines in each case. So these are parallel, and those are parallel. The other lines are not parallel with one another. So if you had two pairs of parallel lines, what would that be? Do you remember that that would be a parallelogram? And a parallelogram is a special type of trapezoid. So these are regular trapezoids, not parallelograms. Okay, so I am going to tell you the formula for finding out the area of a trapezoid. But first I want to show you a little bit of how we get that formula. Now you don't need to know that, but it is interesting to realize how did mathematicians discover or figure out what would the formula be. So nobody invented math exactly. They discovered what would the area of a trapezoid be. So let's look. So let's look at this. So first of all, these two sides that are parallel, those are called the base. Okay. Oops. A different marker. So both of the parallel lines are called the base. So there's two different bases, and the bases are different lengths, so that's a little tricky, but those are both called the bases, and then the height is the distance between the two bases. So just like in a parallelogram, the distance from the base up was the height, and between these two bases in a trapezoid, it is also the height. And it doesn't matter which side is on the top or on the bottom. So you can see this side has the smaller side on top, this side has the longer side on top. It doesn't matter which side you have. Okay, so let's start splitting one of these up and seeing if you could figure out how could we get a formula for this. So if you let's look at this top one. So this trapezoid has a 90-degree angle here. They don't all have 90-degree angle, but this one does. And let's imagine that we cut this up. So now all of a sudden we have a rectangle and we have a triangle. So if we knew the length here and the height here, we could find the area of the rectangle and the area of the triangle, and then we could add them together. So let's say this this whole length here is 8. Let's say this is 6, and this is 4. Well, okay, it's not exact, but let's just go with it. And so we know this height is 4. So the area of this rectangle would be length times width, which would be, so which are we going to use? Are we going to use this 8 or this 6? Well, of the rectangle, it would be the 6. So 6 times 4, that would be 24 for this. So it would be 24. And then the triangle. So if this is 6 and this whole thing is 8, that means this part here is 2. So 2, and then the height of 4. So let's erase this and work here. Okay, so that's for the rectangle, and then for the triangle, base times height divided by 2. So the base is 2, the height is 4, divide that by 2, that will equal 4. So the area of this is 4, and the area of that part is 24, so we could add those together to get the whole area of the trapezoid, so that's 28. So you can, when you find an area of a trapezoid, you can split it up often into a rectangle and a triangle, find those two areas separately and add it together. Now, if you have some of the trapezoids, if they don't have a right angle, then you'll have a triangle on both sides, okay? So you could find this rectangle, this triangle, and that triangle, and add those all together. So this is some of what you'll be doing in your book, but let me show you how they came up with the formula. So I'll try to do that quickly here. Okay, so let's get another trapezoid here. Okay, so we've got our trapezoid, so let's imagine that we have, what we're going to do is we're going to draw some imaginary lines here. And then, so we can see the rectangle. Now we can see a triangle here, a triangle here. So what we're going to do is imagine from here to here, splitting this in half, okay? So we're going to cut this off. Now I didn't do this very well because I can see that does not look like half, okay? So I think this is something that you're going to have to try on your own at home and test this out for yourself. But if we cut this in half, let's just say it's about here. Okay. Okay, this isn't going to work. I wish I could do this in class with you. If we could cut this out and we could try it, it would look really good and it would work. I could see this is not going to work because I didn't draw this perfectly. So I'm going to give up on that for now. What I'm going to say is that if you have this trapezoid, I'll just draw it freehand here for a second. And then you cut these sides a little bit, and you take that triangle and you flip it around in here, and you take this triangle and flip it around down here, you would end up with a rectangle. Okay, so you're going to have to trust me on that, or if you want to, you can design one yourself and try it out and snip it and move it down, and then you would end up with a triangle. So, sorry, a rectangle. Okay, so what I am trying to say here is that the area for trapezoid is 1/2 base plus base times height. Okay, so what you do is you take the area of one of the bases, you add it, the length of one of the bases, add it to the length of the other base, and you multiply that by h, the height, and then multiply that by 1/2, which is really the same as dividing it all by 2, isn't it? So you could also write it like that. Either way is fine. Okay, so let's just try one really quickly here. I think that this will make a lot of sense for you in your book, okay? Okay, so I'm going to draw one of these quickly, and then we'll try this formula. Okay, so let's say this is 5 and this is 7. Our two bases are 5 and 7, and then our height is 3. Okay, so we'll plug that into our formula. So we would have area equals 5 plus 7. Put that in brackets, and then we'll multiply it by the height, which is 3, divided by 2. So 5 plus 7 is 12. Times 3 over 2 equals 12 times 3 is 36, divided by 2, which is 18. Okay, So the area of this trapezoid would be 18. Okay, so I'm going to give you your homework, and I think you'll find it easy. What you're doing basically at first is cutting up trapezoids into rectangles and triangles, finding the area of the two different parts, adding them together for the area of the trapezoid. Okay, so you are on page 182, numbers 1, 2, and 5. So great. Thanks for watching.